this paper called Basis Portfolios. Thank you so much for having me. My name is Sina Seyfi from Aalto University. So basically the research question is how to form the basis portfolios from the universe of all of the stocks that span the mean variance efficient frontier and maximize the out of sample MVE Sharpe ratio, specifically in the presence of the measurement errors. So should we sort the stocks based on some characteristics, or should we sort the stocks based on industries, correlation, expected returns, and all of these methods which have been in the literature. So I start with a very simple assumption that basis portfolios should be as far apart as possible in the mean variance space, meaning that they should have different expected returns and low covariances. And if we assume that the expected returns and covariances are a function of a large set of characteristics, then the basis portfolios should be as far apart as possible in a large set of characteristics. So having this in mind, I propose sorting stocks into decile portfolios with two simple objective functions. The first one is that I sort the stocks to decile portfolios so that stocks within each portfolio should have the most similar characteristics, and equivalently stocks across each portfolios should have the least similar characteristics. And then all of the portfolios should have the same number of stocks. And I measure this similarity of characteristics as the Euclidean distance between the vector of 129 characteristics. Let me visualize a little bit for you. If we have two characteristics, and these are all of the stocks in a given month, how does it look like? So it looks like something like this. So if we have beta short-term reversal, we have the stocks that they are all of the stocks in one portfolios, they are as close as possible in characteristics, and stocks across portfolios are different in characteristics, so they have low co-movement. If we have three-dimensional, so stocks, decile portfolios look like this. And if we had only one variable, my method will be exactly equivalent to the common univariate sort in the literature. So basically my method is in a way generalizing the univariate sort in the literature, and because of this I call this method a high dimensional portfolio sorts. So I use a large set of characteristics while keeping the number of portfolios small. So I show that these high dimensional portfolios show lower correlation, significantly lower, and higher dispersion in expected returns, higher in-sample and out-of-sample Sharpe ratio. They show higher GRS statistics, so they are harder to price. They have a better conditioned covariance matrix. They are more robust to measurement errors, and they show lower minimum variance compared to a large set of alternatives in the literature. To conclude the session, I would like to show you this photo of efficient frontiers. So the black efficient frontier is the efficient frontier spanned by the high dimensional portfolios that I am proposing. And there are 133 other efficient frontiers which are already in the literature documented, either based on either one univariate sort, or based on correlations, based on industry, based on expected returns. And we see that the high dimensional portfolios span the mean variance efficient frontier. Thank you.